In this video, we are going to express several functions as a power series. We can also use differentiation and integration to express some functions as a power series, but in this video, we're not going to be using differentiation and integration. We're just going to be manipulating original function and express it as a power series. So these are some simpler examples of expressing functions as power series. We know 1 over 1 minus x is equal to summation n equals 0 to infinity x to the power n. This series converges if x, absolute value of x is less than 1. This series converges if absolute value of x is less than 1. This all comes from geometric series. Geometric series, if the absolute value of r, which is a common ratio, is less than 1, then sum of infinite terms is a over 1 minus r. So in my case, my a is 1 and the common ratio is x. So this is coming from a over 1 minus r. Now we can express several functions as a power series. So my goal is to express them in this form somehow. Let's see. First of all, we have f of x is equal to 2 over 1 minus x. So we need to have something in the form 1 over 1 minus x. Then we can express it as a power series. I'm going to pull the 2 out and write it as 1 over 1 minus negative x. So it's the same thing. Negative times negative is a positive. So I haven't changed anything. So in this case, my r, the common ratio, is negative x. So summation n is equal to 0 to infinity negative x to the power n, which is 2 summation n is equal to 0 to infinity. N is equal to 0 to infinity negative 1 to the power n x to the power n. That's the power series for this function. That's the power series for this function. And it converges as long as absolute value of x is less than 1. Converges as long as absolute value of x is less than 1. The center in this case is x equals 0. Center is 0. Okay, the interval of convergence in this case is, I made another video on center, radius, and interval of convergence. Interval of convergence in this case would be between negative 1 to positive 1. Okay, let's see another example of expressing a function as a power series. So here's another example. F of x is equal to 3 over 2 minus x. So again, I can write it as 3 over, I can pull the 2 out as well. And 3 halves outside 1 minus x over 2. Now, my common ratio, it's going to be x over 2. So this is 3 halves summation n is equal to 0 to infinity. Where I used to have 1 over 1 minus x, I do have, instead of 1 over 1 minus x, I have 1 minus 1 over 1 minus 1 over 1 minus x halves. So my r is going to be x halves to the power n. So a little bit cleaning up, n is equal to 0 to infinity, 3 over 2 raised to the power n plus 1, because I have 2 to the power n in the denominator, and already have 2 to the first power here, times x to the power n. And that's my power series in this case. This power series converges if absolute value of the center for the power series is x is equal to 0, and I do have convergence if absolute value of x over 2 is less than 1. If absolute value of x over 2 is less than 1, my series will converge. Whatever is the r, the common ratio, that's going to tell me. So between negative 2 and 2, that's where I will have convergence. And I must check the endpoints in this case to find the interval of convergence. Now, for the geometric series, at the endpoints, what's going to happen if I plug x as negative 2? So geometric series, it would not converge at the endpoint. So my interval of convergence would be negative 2 to 2. Because if absolute value of r is equal to 1, which is a common ratio, if that's equal to 1, then we don't have convergence. So for geometric series, there's no convergence at the endpoints, no need to test the endpoints. Same thing for the last one. We did find the center, we found the interval of convergence, and we will never have bracket around negative 1 and 1, because we're not going to have convergence when r is equal to 1. Only when absolute value of r is less than 1. Let's see another example. Here we have f of x. Let's see number 3 first. F of x is equal to x over 1 minus 2x. So how can I express it in a way that I do have the form 1 over 1 minus x? And this x can be something more than the x. It doesn't have to be just x. 1, I can pull the outside, the x in the front outside, and I can say this is 1 minus 2x. So that's going to be x summation n is equal to 0 to infinity 2x to the power n. Cleaning up, x summation n is equal to 0 to infinity 2 to the power n x to the power n. So that's going to be summation n is equal to 0 to infinity 2 to the power n x to the power n plus 1, because I do have x to the first power here. And that's going to be the power series in this case. And this power series converges whenever absolute value of 2x is less than 1. So we would have convergence here whenever your common ratio is less than 1, which is 2x is less than 1. So absolute value of x is between 1/2 and -1/2. So my interval of convergence in this case would be -1/2 to +1/2. And the center in this case is 0. Center is x equal to 0. See next example, number 4. For number 4, we would, well, again, we want to write it in the form. Somehow we want to have 1 over 1 minus x form. That's our goal. So I can pull the 5x outside, and over here I'm going to write it as 4 plus x squared. I'm going to go ahead and pull the 4 out. 5 over 4, 1 over 1 plus x squared over 4. All right, almost there. So 5 over 4, I can write it as 1 minus -x squared over 4. It's going to be the same thing. Negative times negative is a positive. So 5 over 4 is pulled out. Actually, we had pulled 5x outside. So don't drop that x. We had pulled 5x outside. Summation n is equal to 0 to infinity. The whatever your r is, in this case, it's going to be negative x squared over 4 to the nth power. And this series converges when absolute value of x squared over 4 is less than 1. Let's just completely write the power series and then talk about the convergence. Summation n is equal to 0 to infinity -1 to the nth power, x to the power 2n over 4 to the power n. We also have 4 to the power 1 here and x to the power 1 here. So let's go ahead and take them inside now. That's summation 1 to the power n, 5 over 4 to the power n plus 1, x to the power 2n plus 1. And that's the power series. So for this series, we will have convergence whenever absolute value of r is less than 1. In this case, that was x squared over 4 is less than 1. Absolute value of x squared over 4 less than 1. -4 less than x squared. -4 less than x squared less than 4. If I go ahead and take square root, this is going to be, absolute value of x has to be less than 2. Only then. That means my x has to lie between -2 and 2. That's going to be my interval of convergence. Interval of convergence would be between -2 to 2. Okay. So if absolute value of x squared is less than 4, that means, yeah, x lies between -2 and 2. All right. Next, we have example number 5. We're going to express this function as a power series. So first of all, we're going to go ahead and write these using partial fractions. So we can write it as, we cannot, 1 plus x over, oh, no partial fractions. We cannot do partial fractions here, but we can go ahead and write it as 1 over x minus 1 plus x over, 1 over 1 minus x plus x over 1 minus x. Yeah, just writing it as two separate fractions. And this one, we already know what the power series is. This one is easy enough. 1 over 1 minus x is summation n is equal to 0 to infinity x to the power n, and it converges whenever absolute value of x is less than 1. And x over 1 minus x is equal to summation. We can pull the x outside. We can write it as x times, we can pull the x out, 1 over 1 minus x. So that would be x summation n is equal to 0 to infinity x to the power n. Again, absolute value of x has to be less than 1. That will give me n is equal to 0 to infinity x to the power n plus 1, because I already have the power 1 here. When I take it inside, the exponents will add up. Now I do have two different, so I have these two power series. I'm going to add them up to express the power series for 1 plus x over 1 minus x. This can be expressed as an infinite series going from 0 to infinity, x to the power n plus x to the power n plus 1. And again, absolute value of x has to be less than 1. If I do want, I can go ahead and factor out x to the power n, 1 plus x inside, and that's the power series for this function. Absolute value of x has to be less than 1. So absolute value of x has to be less than 1 means x I'll have convergence around -1 to 1. Interval of convergence would be from -1 to 1, and the center was 0 in this case. Center was x equal to 0. Okay, that was number 5. Let's check out example number 6. 1 over 3x. How do I express 1 over 3x as a power series? So what we can do is we can rewrite it as 1 minus 1 plus 3x, right? 1 minus 1 plus 3x, which would be 1 over 1 minus 3x. So now it is in the form 1 over 1 minus x. And it's not x in my case, it is 1 minus 3x. So that's replacing the x. So the power series for this function is going to be summation n is equal to 0 to infinity x to the power n, which is, in my case, x is 1 minus 3x to the power n. And I'm going to leave it at this point. For this one, the center is going to be 1/3. So wherever this piece becomes 0, that's where you have the center. Center is x is equal to 1/3, and it does converge so we will have convergence if absolute value of 1 minus 3x is less than 1. That's -1, 1 minus 3x less than 1. Subtract 1 from everywhere. That's going to give me -2 less than -3x less than 0. Divide everything with the 3 2/3. The sign flips when we divide with the negative number. Divide with the -3. Okay, so that's going to be my interval of convergence. Interval of convergence in this case is going to be between 0 to 2/3. 0 to 2/3. Okay, so this series converges around 0 to 2/3. See another example. F of x is equal to 8 over 2x minus 9. So for this problem, let's see. So I want to express it in the form 1 over 1 minus x. That's my goal. And again, this x can be something more than x, but 1 over 1 minus something, some function of x, some form, some multiple division, some function of x. Okay, so I can pull out 8 halves. Actually, I can pull out 8 halves first. Let's pull out 8 nines. And that would give me 1 over 2 over 9x minus 1, right? 2 over 9x minus 1. Now we do want 1 minus x. We want 1 at the front. So I'm going to pull out a negative. 1 over 1 minus 2x over 9. 1 over 1 minus 2x over 9. Okay. Now that's my r in this case. So I'm ready to express the power series. -8 over 9 summation n is equal to 0 to infinity 2x over 9 to the nth power. Okay, all we have to do is I just have to clean it up a little, and I do know I'm going to have convergence if 2x over 9 absolute value is less than 1. I would have convergence. Okay, so -8 over 9, actually, let's see, 8 can be written as 2 to the 3rd power. So I have -1. I'm going to take everything in the summation just because I'm going to try to do it in one step. -1, 2 raised to the n plus 3, because 8 is 2 to the 3rd power, and I already have 2 to the power n inside. And then I have x to the power n over 9 to the power n plus 1. And that's the power series in this case. And I do have convergence only if only absolute value of 2x over 9 is less than 1, which we can solve to get the interval of convergence. If we want to get interval of convergence, we would get -1 less than 2x over 9 less than 1. So -9 less than 2x less than 9. -9 halves less than x less than 9 halves. So this is going to be my interval of convergence from -9 halves to 9 halves, positive 9 halves. And the center in this case is 0. Let's see another example. Number 7, we haven't looked at. 3 over 4 plus 5x squared. And we want to express it as a power series. So again, think about your goal. You want to go 1 over 1 minus something in the form. So 3/4 I can pull out. I can pull out 3/4. And that would be 1 over 1 plus 5 over 4x squared. Rewriting 3 over 4 inside the parentheses, I would have 1 over 1 minus negative 5x squared over 4. Okay, so 3/4 summation n is equal to 0 to infinity r x to the power n, negative 5x squared over 4 to the power n. That's, we got our power series. We're just going to clean it up a little. We can pull out negative 1 to the nth power in the front, and then we have 3 times 5 to the power n over 4 to the power n plus 1, because we have 4 to the nth coming out. We already have 4 to the first power, x to the power 2n. And that is our power series in this case. 5 to the n, 4 to the power n plus 1. That's our power series for this function. Okay, one more example. Number 9. F of x equals 3x minus 1 over x squared minus 1. I do have a bottom heavy polynomial, so I'm going to go ahead and do a partial fraction for 3x minus 1 over x minus 1. So I'm going to let, actually first of all, I'm going to go ahead and multiply everything. A times x minus 1, multiply everything. 3x minus 1 is equal to a times x minus 1 plus b times x plus 1. Okay, I'm going to let x be positive 1. If x is positive 1, I have 2 is equal to 2b. So b turns out to be 1. Let x be negative 1. If I let x be negative 1, negative 3 minus 1 is negative 4, and negative 2a. So a turns out to be 2, positive 2. Okay, so this fraction can be expressed as a over is 2 over x plus 1, 2 over x plus 1, 2 over x plus 1, and b was 1 plus 1 over x minus 1. Okay, once we have that, it should be very much doable. We should be able to find the power series for individual functions and then add them up. So for 2 over x plus 1, power series would be, let's just do 1 over x minus 1 first. We want to have 1 over 1 minus x. So I'm going to pull out a negative, which is going to be negative summation n is equal to 0 to infinity x to the power n. So I do have a negative sign here, and this only converges if absolute value of x is less than 1. The other one, I can pull a 2 out. And I'm going to rewrite 1 over 1 minus negative x. Turns out to be 2 over n. I'm going to go ahead and again, this converges if absolute value of x is less than 1. Now to express the given function that we had, 3x minus 1 over x squared minus 1, that would be sum of these two power series. So we have 2 summation n equals 0 to infinity negative 1 to the power n x to the power n minus summation n is equal to 0 to infinity x to the power n. Now we can clean it up a little if you want. We can pull out x to the power n. Summation n is equal to 0 to infinity x to the power n. I would have 2 times negative 1 to the power n minus 1. And that's the power series for this function. We can also choose a center for a power series. So if we are given a power series for a given center, we can choose to have a different center for the power series. Here we are given, we know summation xn, n is equal to 1 to infinity, is going to be 1 over 1 minus x. That's the sum of this power series, and the center is at x equals 0. What if I want to write a series for this function, 1 over 1 minus x? I want to write a series for this function, but I want to have the center at x equals negative 1. So how do we do that? So if you want to have the center at x equals negative 1, we want to have 1 plus x in the denominator. So let's go ahead and rewrite 1 over 1 minus x. I can write it as 1 over, we want to have x plus 1 inside if we want the center to be negative 1. So 2 minus, that would be, let's go ahead and add, I'm going to write it as 1 plus 1 minus 1 minus x. The reason why I'm doing that is I am able to do 1 plus 2 minus 1 plus x. Now my center would be, or I can say x plus 1, doesn't matter, you can flip them if you want. The center would be negative 1 in this case now. Okay, let's go ahead and pull out a 2 now. 1/2. We don't want to have a 2 there, we want to have a 1 there. So 1/2 comes out 1 over 1 minus x plus 1 over 2. All right, so this is my new common ratio r, and I can write it as a power series. So I can say 1 over 1 minus x can be also expressed as 1/2 summation n is equal to 0 to infinity x plus 1 over 2 to the power n. And this series converges. We do have convergence if absolute value of x plus 1 over 2 is less than 1. If the absolute value of the common ratio is less than 1, we do have convergence. Now I'm going to clean it up a little. N is equal to 0 to infinity x plus 1 to the power n over 2 to the power n plus 1, because we already had 2 to the first power. So we can express this series with a different center. Now this one has a center x is equal to negative 1. Earlier we saw we can also say this is n is equal to 0 to infinity x to the power n. The center is x equal to 0. So as your center changes, your interval of convergence will also change. When your center changes, your interval of convergence will also change. Interval of convergence will also change as your center changes. Let's check out another example. We want to express the power series for f of x is equal to 1 over 10 minus x with center at x equals 4. So we're choosing a center x equals 4. I'm going to go ahead and try to rewrite it. That means I need to get 1 over 1 minus x minus 4. That's my goal. Somehow I need to get to this point. Only then the center would be x equals 4. So let's rewrite it. 1 over 10 can be written as 6 plus 4 minus x. So this is 1 over 10 minus x. I can rewrite it like that. 1 over 6 minus 6 minus x minus 4. Yep, if I pull out a negative, this would be x minus 4 now, because x would become positive. I factored a negative sign out. So it's kind of looking like that, but I also don't want to have a 6 over here. So 1 over 1 minus x minus 4 over 6. Looks like that's going to be my r in this case. That's what's replacing x. 1 over 6 summation n is equal to 0 to infinity x minus 4 over 6 to the power n. Now all I have to do a little bit cleaning up, and I do know that I'm going to have convergence in this case only when r, absolute value of r, convergence when absolute value of r is less than 1, which is absolute value of x minus 4 over 6 is less than 1. So let's go ahead and do n is equal to 0 to infinity x minus 4 to the power n over 6 to the power n plus 1. Now I'm going to be, that's my power series, which is equal to 1 over 10 minus x, and we chose the center 4 in this case. Center x equals 4. As the center changes, your interval of convergence will also change. So convergence in this case, I'm going to have when x minus 4 lies between negative 6 and 6 when I get rid of absolute value sign. So negative 6 plus 4 is less than x 6 plus 4. So that means negative 2 and 10. Between negative 2 and 10, I'm going to have convergence in this case. So negative 6 plus 4 is negative 2, 6 plus, yeah. So convergence, I would have convergence. Interval of convergence is going to be, interval of convergence would be between negative 2 to 10. So I'm starting from 4. What's going to be the radius of convergence? Radius of convergence is from 4, I'm going up to 10, and I'm going up to negative 2. Radius of convergence is 6 in this case. Okay, that's all for this video. So we saw several functions that we expressed as a power series in this video.